Hey guys, welcome to Tapso Spaces. In this video, we will learn about pointers. Let's start with a simple analogy. You might have visited some supermarkets where the baggage handler will collect your bag and keep it in the baggage counter. As soon as you give your belongings, he'll provide you with a coupon from which he can recognize your bag from different ones. The coupon will have a number which will be identical to the number on the baggage counter. So that coupon can be used to access your bag which is stored in the counter by its number. In the same way, we can access a variable by mentioning where it is stored in the memory. We use pointers to achieve this. You can compare your baggage to the data, the baggage counter to the memory, and the counter number to the memory location. Now, to understand more about memory location, let's see what happens inside the memory when you declare and define a variable. Memory is also like a baggage counter, but for variables with respective memory locations. I have chosen some random memory locations for the purpose of demonstration. When you declare a variable, some bytes of data in the memory will be reserved for that variable depending upon the data type of the variable. Since the data type is int, it takes 2 bytes of memory. If it was float, then it would take 4 bytes of memory. This variable now has a memory location inside the memory. When you define it, the data will be stored inside that memory location. To access this variable, you can simply mention the variable name, but using pointers, we can mention the memory location from where the data needs to be accessed. Memory locations are also referred as addresses. So, this memory location is called address of A. We use ampersand operator to refer to the address of a particular variable. So, ampersand A should give us the address of A, that is 3002. %u is the type specifier to print an address. %u is used as a type specifier instead of %d because %d will consider positive and negative values. But addresses doesn't have a negative value. Unsigned will only consider positive values. So now we know what is a memory location. Now let's discuss about pointer variable. It's a variable which stores the address of another variable and points to the memory location where that variable is stored. It requires declaration just as any other variable. The syntax of declaration is very simple. Specify the data type and mention the pointer operator and the variable name followed by a semicolon. Here's an example. I've declared data type as int and variable name as ptr. Now, when you declare just as any other variable, some bytes of data is reserved for ptr variable in the memory in some memory location. In the definition, it's clearly stated that a pointer variable will store the address of another variable. So, let's declare another variable a and initialize it with 10. Now, a also has some space reserved for it in the memory with its own memory location or its address. We have already learned how to get the address of a variable. Let's store the address of a in ptr variable. Now ptr has the value 3002 stored in it. We can access the data of a with this pointer variable. We use pointer operator to achieve this. If I just print ptr, 3002 will be the output because the value of ptr is 3002. Now let's come to the next statement. It is read as value at address in ptr. We know the address in ptr is 3002. So the value at 3002 will be 10. Therefore, if I print the pointer of ptr, 10 will be printed. Hence, we say ptr is pointing to a because we can access the value of a through ptr. Note that the addresses may vary in your system when you try executing. Remember, the data type of the pointer variable and that of the stored variable should be the same. That is, if you want the pointer variable to point to a float type, the pointer variable should itself be a float type. It goes same with other data types like char or double. Let's look at an example to add two numbers using pointers. We need two variables to add. Let's declare and initialize them with 10 and 20. We need another variable to store the sum. Let's also declare two pointer variables as ptr_a and ptr_b. Now assign address of A to ptr_a and address of B to ptr_b. Now 3002 and 3845 is stored in ptr_a and ptr_b respectively. The value at address in ptr_a will get you 10 and value at address in ptr_b will get you 20, since ptr_a is pointing to A and ptr_b is pointing to B. Now adding those and printing the sum will give you the output as 30. Now I can hear you saying, why are you making addition of two variables so complex? Remember, this is not the perfect use case of pointers. This was just to introduce you to the pointers. A general use case of pointers is to pass variables by reference. Let's see how. I hope you're familiar with swapping of two variables. In this example, we have declared A and B and initialized them with 10 and 20. The swap function takes in these variables and swaps them. If you are not familiar with functions, don't worry, I have made a tutorial on it. The link is provided in the description below. Look that up and continue watching this tutorial because you need to know how functions work to understand this example. Also note that we are printing these variables in the main function and not in the swap function. Can you guess what values will be printed here? If your answer is 20 and 10, kudos, but your answer is wrong. Surprised? Yeah, the variables are not swapped when we run it. This happens because of something called scope of a variable. It's simple. You see, A and B are declared in the main function, hence they are accessible only in the main function. While passing an argument to a function, a copy of these variables are only passed but not the actual variables. And scope of those copied variables will only be in that function itself. So these variables have scope only in swap function. Hence printing A and B will not print these variables but print these variables which are not modified. Hence the output is 10 and 20. Passing variables by reference or by address will solve this problem. As in this example, if addresses are passed as variables to the swap function, then to hold them a pointer variable is needed because normal variables cannot hold addresses. So pointer variables are declared here. Now if we look into the memory, let's say A is stored in 2014 and B is stored in 2840. Since the address of A is 2014 and address of B is 2840, these are passed to the swap function. We already know that the value at address in ptr_a will get you the value that is stored in 2014, so this will be 10. And similarly, this will be 20. Hence, we have accessed the value of A and B through their addresses. Now, let's visualize how swapping actually happens in the memory. In this step, the pointer of ptr_a, that is 10, is stored in temp. In this step, the pointer of ptr_b, that is 20, is stored in the pointer of ptr_a, that is in 2014. And finally, temp is stored in the pointer of ptr_b, that is in 2840. Now, if you look at the scope of the variables, even though these variables are in the scope of the swap function, these are the addresses of the variables that are in the scope of the main function. When you do anything with address, the scope of a variable doesn't really matter because you're accessing the variables by its address. Now, when we run this code, the output is as expected. Pointers are mainly used in dynamic memory allocation, which will be covered in future videos. Do subscribe and press the bell icon to get a notification. Okay, now let's talk about the size of a pointer variable. The size of a pointer variable varies from compiler to compiler. In a 16-bit compiler, the size of a pointer variable is 2 bytes, whereas in 32-bit compiler, the size of a pointer variable is 4 bytes. There's a common misconception that the size of a pointer variable depends on the data type, but it's not. As in this example, let's say there's an integer pointer, character pointer, and a double pointer, and variables with these data types. When addresses of these variables are stored in the pointer variable, remember, a pointer variable stores the address and the address is independent of the data type. That's why the size of a pointer variables of different data types turns out to be the same. Note that it may vary depending upon the compiler in your computer. Let's end this video here. Thank you for watching this video. If you have any doubts or wish to give any feedback, please do in the comment section below. Also, visit Tabs Over Spaces website, which features this YouTube channel, and also you can contact me by filling this simple form and submitting it, and also you can know more about me. The link is provided in the description below. Thank you.